Hi students, in this video I'll be going through the 2014 O-Level Additional Mathematics Paper 1 question 11. Alright, so let's read the question. So the point P lies on the curve y equals to x ln x. The tangent to the curve at P is parallel to the line y equals to 2x minus 3. Okay, so we may not know how this curve looks like exactly. Okay, so we can just draw a rough sketch to help us to visualize it better. So over here, you can see this brown line represents the curve y equals to x ln x. Okay, then at this point P, you will be able to draw a tangent. And they say that this tangent is parallel to this line y equals to 2x minus 3. Alright, so we know that when two lines are parallel, their gradients will be the same, right? So in other words, the gradient of this tangent is also going to be 2. Okay, because the gradient of this line is 2. Alright, so we can actually write that down first. So gradient of y equals to 2x minus 3 is 2, right? Okay, so therefore, gradient of tangent at P is equals to 2. Okay, we also know that the gradient of the tangent at P can be found by dy dx. Okay, so it's actually dy dx, the gradient function. Okay, so basically what we need to do now to find the x coordinate of P would be to do dy dx to the curve to get the gradient function. Then we equate the gradient function to 2, okay, because the gradient of the tangent over here is 2, right? Okay, then after that we solve for x and we should be able to find the x coordinate of point P. Okay, then once we get x coordinate of point P, we will sub it back into the equation y equals to x ln x, then that will allow us to find the y coordinate of point P already. Okay, so let's go ahead and try to do dy dx first, right? So y equals to x ln x. Okay, so over here you have two terms, x and then times ln x. So in this case, we will need to use the product rule. Okay, so you should be quite familiar with the product rule. Okay, so for product rule, we keep the first term, then we differentiate the ln x. So when you differentiate ln x, you will get 1 over x. Okay, then we plus. Okay, now we will differentiate the first term. So you will get differentiating x will give us 1, and we'll keep the second term. Right, so in this way, we will get x times 1 over x will be 1 plus ln x. Okay, so dy dx will be 1 plus ln x. Okay, so as mentioned, we are going to equate dy dx to 2. Alright, so what we can write is that P dy over dx will be equals to 2. Okay, then now we're going to form the equation. So 1 plus ln x will be equals to 2. So ln x will be equals to 1. Okay, so we know that 1 is actually ln e, right? Okay, so we can actually write it this way. Okay, so therefore x will be equals to e. Okay, so the x coordinate of point P is going to be e. Okay, so now we're going to sub it back into the equation, original equation, this equation actually, okay, to allow us to find the y coordinate. Okay, so substitute, okay, let's call this equation 1, okay. Okay, equation 1, substitute x equal to e into equation 1. Okay, so y will be e ln e. Okay, so we know that ln e is 1, right? So it will be e times 1, so you'll get e. Okay, so in other words, the coordinates of p, okay, is going to be e, all right? Okay, so interesting answer, right? So the coordinates of p will be e. Okay, let's move on to part 2 of the question. Okay, so they say that the normal to the curve at y equals to x ln x, right, at P, meets the line y equals to 2x minus 3 at the point Q. Okay, so where is the normal? So the normal is always 90 degrees to the tangent. So if I were to draw the normal, it's going to look something like this, right? Okay, so this one is the normal, 90 degree perpendicular to the tangent, and they say that it meets the line y equals to 2x minus 3, right, at this point Q. So they want us to find the coordinates of point Q. Okay, so whenever you want to find the coordinates of the intersection between two lines, right? Okay, what we're going to do is we're going to solve simultaneously. All right, we're going to solve the equation simultaneously. Okay, but in order to do that, we need to first find the equation of the normal. So the normal is perpendicular to a tangent, which means that we can find the gradient of normal easily. Okay, so gradient of normal So at P, okay, gradient of normal times the gradient of the tangent, which is 2, will give us -1. Right, so the gradient of the normal will be -half. Okay, so the normal also passes through the point EE. Okay, in other words, we can find the equation of the normal already. Okay, so let's find. So equation of normal at P, okay, will be y minus y1. So remember the coordinates of P is EE, right? Okay, so y minus y1 equals to gradient m x minus x1, right? So y minus e equals to -half x plus e over 2, right? So we're going to bring over. Okay, so e over 2 plus e. Okay, so you'll get 3e over 2. Okay, so this will be, let me call this equation 2. Okay, and then after that, y equals to, we're going to solve simultaneously with y equals to 2x minus 3. Okay, so the gradient of this equation of this normal, we just found it to be y equals to -half x plus 3e over 2. Okay, so we're going to solve simultaneously with this. So I call this equation 2, and then this will be equation 3. Okay, so y equals to 2x minus 3. Let's call it equation 3 now, okay? Because on top I've already labeled equation 1 already. So let's call it 2 and 3. Okay, so we are going to equate 2 and 3. So equate 2 and 3. Okay, so we're going to get 2x minus 3 equals to -half x plus 3e over 2. Okay, so we're going to bring all the x terms to one side. So 2x plus half x equals to 3e over 2 plus 3. Okay, okay, so this will give you 5 over 2x. Okay, 5 over 2x equals to, okay, so this one we're going to perhaps, okay, we'll leave it first. Okay, we try to get rid of denominator. Both sides have denominator 2, right? So let's multiply by 2. So you'll get 5x equals to 3e plus 6, right? Okay, then from here you need to look at the final answer. They want you to show that the coordinate of Q is in this form. Okay, you see an e plus 2 here, right? So what can we do over here to get e plus 2? Okay, what we can do is we can factorize out the 3. Okay, so e plus 2. Okay, so only one final step, divide the 5 over. So you get 3 over 5 e plus 2. Okay, so they say that where k is a constant to be found, so you can compare. So k is going to be 3 over 5. Okay, so therefore k equals to 3 over 5. Right, so the answer is over here. Okay, so you can see that the question is actually not that difficult. You just have to understand the concepts very well, and you'll be able to solve the question successfully. All right.